In this video, we'll be solving this integral. Okay, so first notice that we have two tangents in the denominator, and then the derivative of tangent will be secant squared in the numerator. So it's good to let u be tangent of x, so then du will be secant squared dx. Now this simplifies the integral as just du over the square root of 4u minus u squared. At this point, we want to complete the square. So this is going to be a little complicated, but in order to complete the square, you always want to add the term b over 2 quantity squared. So for us, we have 4u minus u squared, which I'm just going to rewrite it as minus u squared plus 4u. b in this case is 4. So take 4 divided by 2 and then square it to also get 4. But because we added 4, we also want to subtract 4. Okay, now I'm going to rewrite this. I'm going to bring this 4 out in front. So it'll be 4 minus u squared plus 4u minus 4. Okay. And then I'm going to factor out the negative. So we have 4 minus the quantity u squared minus 4u plus 4. Until finally we get 4 minus the quantity u minus 2 squared. So this is what we need to proceed. So we're going to replace 4u minus u squared with 4 minus u minus 2 quantity squared. And now we're going to let v be u minus 2 over 2, so then dv will be 1/2 du. And the reason behind this is I would love to have a 4 in front of the u minus 2 squared. Because if I had a 4 in front of the u minus 2 squared, I can factor out a 4, and I'll just have 1 minus u minus 2 squared, which will just end up having this be v. So it'll just be 4 times the quantity 1 minus v squared. And this is a lot easier to find the antiderivative of, as you'll see. Okay, so du is twice dv. So solving for du here, we get twice dv. We replace that. U minus 2, well, if v equals u minus 2 over 2, 2v is equal to u minus 2. So replace that with 2v. And now square it. 2v squared is just 4v squared. Notice they both have a factor of 4. So pull that out. When you pull it out, it becomes 2 because you have the square. The 4 is inside the square root. Pull it out as 2, and it's going to cancel out with the numerator 2. So then you just have the integral of dv over the square root of 1 minus v squared, which that is just the inverse sine of v plus c. So now we're done with integrals. It's just a matter of substituting back. V, we said, was u minus 2 over 2. So replace that with v. And then we need to make another substitution, since we did 2u substitutions, and replace u with just tangent. So our final answer is inverse sine of tangent of x minus 2 all over 2 plus c.